Okay, let's have a look here at this question. What have we got? First, prove this. Okay, I think that was a proof in another exam. All right, so Z1, Z2 conjugate, that's equal to X1 plus I1 conjugate times X2 plus IY2 conjugate, which is equal to X1 minus IY1 times X2 minus IY2, which is X1 X2 minus I X1 Y2 minus I X2 Y1 plus I squared Y1 Y2. So that's minus Y1 Y2. And then Z1 conjugate Z2 conjugate, that's equal to X1 minus I Y1. And then, oh, actually, I've done that backwards. What I've done first is that. So now I need to do that. Okay. So conjugate the whole thing. X2 plus I Y2. So now I'll have to multiply it out and then conjugate. So that's X1 X2 plus I X1 Y2 plus I X2 Y1 minus Y1 Y2. So conjugating means you change the signs on the i's. So that's minus I X1 Y2 minus I X2 Y1 minus Y1 Y2. And you can see that in both cases the result is the same. So therefore Z1 conjugate times Z2 conjugate and Z1 Z2 conjugated is the same thing. Next, got another proof actually. Okay. We have to do it for the division now. All right. I might as well take the same approach. You want to prove that the conjugate, so Z is Z1 over Z2. So the reason they write it like this is a little bit unclear if you just put the conjugate on the top, but what they're trying to say is if you conjugate Z1 over Z2, it's the same as the conjugate of Z1 over the conjugate of Z2. So sometimes people use a star for conjugate. So it's like saying the conjugate of Z1 over Z2 is the same as the conjugate of Z1 over the conjugate of Z2. I think I'll apply the same approach. I'll just do each one separately. So let's start with this one here. So that's X1 plus I Y1 over X2 plus I Y2 conjugate. Now we'll have to rationalize. So that's X1 plus I Y1 times X2 minus I Y2, and then X2 plus I Y2 times X2 minus I Y2. So on the top, what do we get? X1 X2 minus I X1 Y2 plus I X2 Y1, and then I by minus I is minus I squared, so that's plus Y1 Y2. And then on the bottom you're left with X2 squared plus y2 squared. Hopefully we get the same thing now when we look at z1 conjugate over z2 conjugate. So that would be x1 minus iy1 over x2 minus iy2. We'll multiply above and below by x2 plus iy2 and x2 plus iy2. So on the top we get x1 x2 plus I x1 y2 minus I x2 y1 plus y1 y2 over x2 squared plus y2 squared. Let's check, compare. So I've got an x2 squared, y2 squared, y2 squared, x1 x2, x1 x2, y1 y2, y1 y2. I x1 y2. Oh. Maybe I made a sign mistake. Hopefully that's all I did. Oh, no, I can see what I did wrong. I forgot to conjugate this. I forgot about my star. So that actually flips the signs on the i's, so that becomes a plus and that one becomes a minus after you conjugate. I forgot about the conjugate. So now that's I x1 y2, that's I x1 y2, and then that's minus I x2 y2 minus I x2 y2. Yeah, it works. Okay. Yeah, forgot about the conjugate. I was focused on rationalizing the denominator. So good, they're the same. So therefore, z1 over z2 conjugate the answer. That's the same as the conjugate of z1 divided by the conjugate of z2. Okay. Great, great. A little bit messy, but it works. It's not too bad once you don't forget your conjugate symbol. Illustrate set A. Illustrate the set A of solutions. Okay. So that's 4i. And basically it's going to be a circle. And it's going to go as far down as minus I because the radius is 5. It's a circle centered at 4i, radius of 5. Yeah. Okay, so that's that. And then we have another set B, which is located at, you have to change the signs here, it's more like this, z minus 6 minus 4i less than or equal to 5. So that's set B. So at 6 minus 4i, you have another circle. Now, because that's a 6, and that's a minus 4i, and the radius is less than 5, less than or equal to 5. So it will cross over the imaginary axis, but it won't quite reach the real axis because that's 6. Oh, sorry, no, I said that the wrong way around. It will reach the real axis because that's only 4 units away, but it won't reach the imaginary axis. So the circle is like here. If it was 5. But actually it's not 5, it's k. So we need it to be just about no intersection. So they just about touch is what's happening here. So I think what I would need to do is just get this distance here and then subtract 5 units from it so I can know what this radius is here. Yeah, so if I just draw that line, or that triangle, or I'll just use a bit of coordinate geometry. So the distance would be the square root squared plus squared. So it's, if you think about it as like coordinates, it's a little bit like the first one is at 0, 5, and the second one is at 6 minus 4. So it's x1 minus x2 squared plus y1 minus y2 squared. So that's the square root of 36 plus 81. What's that? Is that 11? That would be nice. No. 3 root 13. I don't like that at all. 0, 5, 6 minus 4. 0 minus 6. Alright, fine. Fine. So the k would be 3 root 13 minus 5. Yeah, so it's about 5. It's 5.8. That looks believable from my very rough graph. Okay. And lastly, we just want to transform our set. Okay. So we have the set z minus 4i less than or equal to 5. And then we have the transformation z gets flipped to minus z and the conjugate. So what would happen to the center of the circle? I think that would be the interesting thing here, because the radius is not going to change under such a transformation, just the location of the center. So for example, if you had 0 plus 5i, if you conjugate that, you get 0 minus 5i, and then you have to minus it as well. So you're actually just back with 0 plus 5i. So I don't think the center is moving anywhere. So it's possibly the same thing. Now that happened in the year I did yesterday. I think it was 1979 or 1980. So just like yesterday, I would like to prove that it's the same. So let's see what we get. So this would now become minus z conjugate minus 4i less than or equal to 5. That becomes minus z conjugate plus 4i less than or equal to 5. So that becomes modulus of minus 1 times z conjugate plus 4i less than or equal to 5. So that's modulus of minus 1 times modulus of z conjugate plus 4i less than or equal to 5. Modulus of minus 1 is gone. So now you're just left with the modulus of z conjugate plus 4i less than or equal to 5. And now we can conjugate both sides. So conjugate the z, you're just left with z. And then conjugate the 4i, you're left with minus 4i. And conjugate the 5, you're left with 5. So it's the same set. Nothing has changed. So if you think about the transformation, if you conjugate something, you flip it down the y down vertically. So this point here would get flipped down here, and if you minus it, you flip it over to this side here. So if you have your circle here, wasn't it? So I think what's happening, but that doesn't seem right from my graph though, does it? Because it feels like this should go down here and then this gets moved over here. So maybe my mistake is thinking that the radius stays the same. Maybe it doesn't. But I proved that it stays the same here. Maybe my graph is just really bad. I can go back to it. Oop. I want to see what happens if I actually pick a point that's not the center and follow where it goes. So I'll just remove this here, make a bit of space. So I'm going to take this point here, which would be 5 plus 4i. Okay, so if I conjugate it, that becomes 5 minus 4i. And if I minus it, that becomes minus 5 plus 4i. Oh, I said minus and flips it through this way. That's not quite what it does. It flips it through that way. So what happens is this moves down and then goes through the origin back up here. Yeah. So yeah, okay. It's right. Yeah. I just needed to get the mental transformation picture correct in my head. Okay. I think that's okay. Oh, I've just spotted that it says k is a natural number, and that's not what I got earlier. I didn't see that. Okay, good thing I just saw it now. So I just need to change my answer to a natural number. Well, I do remember I said my answer was something like 5 point something. So funny enough, I think that it turns out the maximum k then is then 5 earlier. I missed that it said about the natural number. So I can't. Oh yeah, I still have it on my calculator. It was 5.816. So the biggest that k could be, it turns out, is also 5. Okay. Okay, I think that's okay. Just before I close the video, I just want to double check that k. Yeah, it's 3 root 13 is the total distance, but 5 units of that is for the first circle, leaving the other one at most 5.816. But since k has to be a natural number, k is 5. Okay. Now I think I'm okay. Yeah. Okay. So to finish it off, f of set A is still A as well. There we go.